Hi there, everyone. We're here today. We're going to talk about vectors and scalars. And by the end of this video, you should be able to identify some basic things about vectors and scalars. And given a vector or a scalar, you should be able to identify whether a quantity is one or another. So let's get down to some definitional things here to begin with. Okay, so basically what it comes down to here, we have this thing called a scalar. And a scalar is a quantity that has only magnitude. All right, this is just the size of something. So I want you to think of, when you hear this word magnitude here, I want you to think of simply thinking of the size or even the amount of something that a quantity might have. A vector, on the other hand, in order to have a vector, to qualify for a vector, you have to have both magnitude or size, and it has to have a direction. Now, some of the quantities we deal with in this class will have both a magnitude and a direction, so that makes it actually a vector quantity. Now, just a real quick note about when we talk about the direction of something. You know, if we talk about something that's happening, we could say it's going up, it's going down. These are directional ways of saying things. We could also say things like east. We could say north. I could say to the right. Basically, any way of saying direction as long as we can say that with whatever we're talking about, we have defined this thing as a vector. Something else to note in this class is that mathematically speaking, these two things are actually equal. All right, now I want to make a clear distinction that even though mathematically these are equal, I am saying these are two different things. This thing right here is a scalar. This thing right here is a vector. Now, I didn't spell that right, did I? How about I put a little c in there? Basically, what makes this thing right here a scalar is the fact that this thing is saying 3 meters. Over here, we have 3 meters as well, but we have this little extra thing here in the front, the positive sign. The positive is also a good way of indicating a direction. So we have the direction right here, and this is the magnitude. Notice over here, this only has a magnitude. All right. So when we think about, if we could think about a number line, moving on one direction on the number line is the positive direction. Moving on the other side of this would be the negative direction. So I want to be clear here, if you ever see me write a positive, I am telling you that the thing that we're dealing with is, in fact, a vector. Okay, so what I'd like to do at this point, I'd actually like you to go ahead and stop the video. I have some I have some different quantities over here. I'd like you to take them, and I'd like you to place them in the appropriate scalar or vector column over here. So go ahead and stop the video now, and pick up with me once you've finished. Okay, so let's see how well you did here. The first one we have is 30 feet. Now 30 feet, because it has no direction associated with it, it actually belongs in the scalar section. It is in fact a scalar. We have the next one, 70 meters per second, east. East is a direction, so therefore 70 meters per second east is a vector. We have 125 kilograms. 125 kilograms has no direction, so it belongs in the scalar. We have 5 newtons. N stands for Newton, unit of force. It has a direction of down, therefore it is a vector. We've got 9.8 meters per second squared. That's a unit of acceleration. It has a direction, so it belongs in the vector. We have a negative 30 feet. The 30 feet is the magnitude part of this. and the negative sign would indicate to us that it is a direction. So that belongs also in the vector side of things. So just to recap, a couple things here that you should need to know is that a scalar has size only. So size in units. A vector is something that has both the size. So it can easily get confused with a scalar, but the thing that distinguishes it from a scalar is the fact that it must have direction.